Okay, in this video, we are asked to find the area between sine of 2x and cosine x. And here we're given a specific limitation. Specifically, since sine and cosine continue on forever, we do need to have a limitation. So sometimes we're going to be given a constraint on the x-axis, and that's the case here. So what I've gone ahead and done using Desmos is I have graphed my sine and cosine functions here. So the sine function, sine of 2x, I have graphed here in black. And you can see it's this shape coming up here and down and back. Now I've also marked pi on here as a vertical line so I know where everything stops. And then cosine x here is graphed in red. And what I want you to observe here is that the red graph is on top for this first section of the graph, right? For this chunk of area here. The red function is on top. But then when we pass through the point pi over 6 here, the black function switches to top. But then when we pass pi over 2, they change places again until finally when we pass 5 pi over 6, the black function is on top again. So we actually end up with 4 different regions that we have to address here because of how it's changing. Which function's on top, which function's on bottom. Now, we could also find those values without having a graph in front of us, but boy, it's so much nicer when we have an actual graph. Right? We could take and solve sine 2x equals cosine x, do some trig identities, and come up with those points. With some work, we could do that. But it's a whole lot nicer when we can just use a graph to be able to pick out that information. And that's a really nice feature here with Desmos that we can do that. Okay, so what we notice here is, first of all, again, red graph, cosine is on top for the first part. Then sine's on top. Then cosine's on top again once we pass pi over 2. Sine's on the bottom. And then finally, sine is on top again for the last little piece there from 5 pi over 6 to pi. And the red graph cosine is on the bottom. So what that means is because we have 4 separate intervals, we're actually going to have to do 4 separate integrals. Okay. The good news is the approach to working out the integrals for most of them is all about the same, so we'll be all right. Okay, so let's set about doing that. So first of all, again, red graph's on top, so cosine's on top. So from 0 to pi over 6, we will be dealing with cosine x minus sine 2x dx. And then from pi over 6 to pi over 2, we're going to be dealing with the flip-flop sine of 2x minus cosine x dx. And then third one, from pi over 2 to 5 pi over 6. It's flip-flopped again where cosine's on top. Cosine minus sine 2x dx. And then finally, our last one, integral from 5 pi over 6 to pi, where it'll be sine 2x minus cosine x dx. Now, for every one of these integrals, cosine, we can do its integral, no problem. But all 4 of them have a sine 2x in there. So for the sine 2x part, we are going to have to do a substitution. U equals 2x. du is going to call for a 2 to go with my dx. Well, if I was putting that together just for the sine 2x integral, since I need a 2 to go with the dx that's not there, I would have to put a 1/2 outside. I'd have my sine 2x, and now I have the 2 to go with the dx. So every one of those signs, when we do the integral, is going to have a 1/2 in front of it once we do the integral. Okay, and so then we're ready to start working this out. So first of all, we have integral of cosine. We know that cosine behaves the opposite of what sine does. Remember, the derivative of cosine is negative sine. So the antiderivative of cosine will be positive sine. Right, so that's integral of cosine will be sine. And now we have minus sine 2x, which is again going to need a 1/2. Remember, sine when integrated is negative, so the minus is actually going to make that plus 1/2. And now that'll become cosine of 2x. And that's going to be evaluated between 0 and pi over 6. And our second one is going to have a sine 2x. Sine when integrated is negative. And remember, it's going to have the 1/2 because of the 2x. So that's going to be negative 1/2 cosine 2x. And then integral of cosine is just sine. So it's going to be minus sine. That's going to be evaluated between pi over 6 and pi over 2. And then we keep going, plus the third one here, integral of cosine will be sine. And again, because of the minus, it's going to be sine integrated is negative, the minuses go away. So it'll actually become, once again, plus 1/2. Integral of sine is cosine 2x. And that's going to be evaluated between pi over 2 and 5 pi over 6. And the home stretch, this is a long one, I understand. It's going to have basically the same integral as the previous one. Right? Integral sine 2x is going to be a negative 1/2 cosine of 2x. Integral of minus cosine will be minus sine x. And that will be evaluated between 5 pi over 6 and 5. Okay. And then it's just a matter of us going in and computing all of those things. It's a lot of things to compute, but fortunately they're all pretty much exact values for sine and cosine. So, of course, you could go into a calculator, but boy, it would actually probably, if you did this with a calculator and wrote all the stuff out and didn't make any mistakes, it'd probably take you about as long as it's going to take us to do this here by hand. So that's what I'm going to do by hand. Sine of pi over 6 is 1/2. Sine of pi over 6 is 1/2. Sine of pi over 6 is 1/2. Okay, that's going to be plus 1/2 cosine of twice pi over 6. Twice pi over 6 is pi over 3. Cosine of pi over 3 is 1/2, so we're going to have 1/2 of 1/2, which will be 1/4. Right? And then that's minus sine of 0, which is 0. And then half of cosine of twice 0. Twice 0 is still 0. Cosine of 0 is 1. So that's going to be minus 1/2. So that's where we're at so far. Okay, and then we move to the next one. We're going to evaluate first at pi over 2. So This is going to be cosine of 2x. 2 times pi over 2 is pi. Cosine of pi is a negative 1, which goes with the negative 1/2. And so negative 1/2 times negative 1 makes that plus 1/2. And we have sine of pi over 2. Sine of pi over 2 is 1. Because of the minus sign, it's going to be minus 1. And we're subtracting all this stuff. Okay. 2 times pi over 6 is pi over 3 again. We know that cosine of pi over 3 is 1/2. It has a negative, but it's part of the subtraction problem. So the subtraction problem cancels out that negative, making it plus 1/4. And then we go again with sine of pi over 6, which is 1/2. It has the negative in it though, so it's going to be plus 1/2. Now, before I continue to the other two here, let me just underline these groups. So I want to kind of keep track of them as we work them out. As we go to the third step, sine x plus 1/2 cosine 2x. Evaluating that at 5 pi over 6. Well, sine of 5 pi over 6, it's a reference angle of pi over 6. Sine of pi over 6 is 1/2. It's in the second quadrant, so it's going to be plus another 1/2. Okay. If you take the angle and multiply by 2, it becomes 5 pi over 3, which puts us in the fourth quadrant. With a pi over 3 reference angle, where cosine again is 1/2. 1/2 of 1/2 is 1/4. Okay. And then we subtract off the pi over 2 stuff. Sine of pi over 2 is 1, so that's going to be minus 1. Twice the cosine of twice pi over 2 would be pi again, which will be negative 1. To make that negative 1/2, but it's being subtracted, so it becomes plus 1/2. And I'm going to underline those 4 as well. And then we finally go to the last one here with pi. Twice pi is 2 pi. Cosine of 2 pi is 1. So that one's going to be a minus 1/2. Sine of pi is 0. So I have a minus 1/2, minus 0, or plus 0. Either one's fine. And then we plug in the 5 pi over 6 stuff. Again, cosine of twice that will be 5 pi over 3. It's in the fourth quadrant with a pi over 3 reference angle, so that will be 1/2. Times the negative 1/2 would make it negative 1/4, but it's the second part of the integral, so it's being subtracted. So that will actually be plus 1/4. And then finally, the last one, sine of 5 pi over 6 is 1/2. It has the negative sign in front, but it's being subtracted in the definite integral. So that would actually make that plus 1/2. And so we have our last group there. Okay. And then it turns out every one of these groups, if you combine stuff, this first blue group is 1/4. Second blue group, 1/2 minus 1 plus 1/2 plus 1/4 is another 1/4. And over here, 1/2 plus 1/4 minus 1 plus 1/2 again leaves us with a 1/4. And then finally, the last one there, negative 1/2 minus 0 plus 1/4 plus 1/2 leaves us with another 1/4. So in grand total, the area between sine 2x and cosine x between 0 and pi is actually 1. A lot to that one. Really big mess because of all the sines and cosines. The fact that we had to do multiple integrals. Definitely a a very long problem, but hopefully you're able to follow that and again follow through the different computations there.